Okay, good day everyone. My name is Afolabi once more, and we are here to have our mathematics section once more. And I've been receiving comments from the previous video and keep them coming. And today we are moving to probability, which is a very, very important topic in mathematics. So many of you usually downplay this topic because it's either you don't really understand or you feel it is very, very easy. But we have so many things under probability today. We are going to be looking at the definition of probability, the terms that are involved, which is sample space, event space, complement, the range of probability, the types of events, okay, the use of table and the tree diagram, binomial probability, and Poisson distribution. These are the things we are going to be looking at throughout the course of probability. So we are not going to waste time at all. Let's start off with definition. So what is probability? So probability is the ratio of the required outcome of an event to the possible outcome, the total possible outcome. Okay, so when you have the required outcome to the possible outcome, then that is probability. For example, or basically what I mean mathematically is that your probability of an event is the required outcome over possible outcome. The number of required outcome over number of possible outcomes. So what does this really mean? If you have a basket, for example, in a basket of 6 red and 8 yellow ball, what is probability of picking a red ball randomly? Okay, what's probability of picking a red? Randomly simply means by closing your eye. You have a red ball and blue and yellow ball in a basket, okay, and you close your eye to pick a particular ball. That's the meaning of randomly. That is, you did not intend to pick a red ball. So what will be the possibility of you picking a red ball? So let's look at what we mean by the event. What's the event? The event in this case is the ball you want to pick. The one you intend to pick is red. That's the event. Okay? The event means you want to pick a red ball. Now the required outcome. What's the required outcome? The number of required outcome. Which is how many red balls that are there you could possibly pick. You have 6 of them. You could pick 6 red balls because we had 6 of them. Then number of possible outcome, that is the total number of balls that you have there, is what? 6 plus 8, which is 14 balls. So that's what I mean by the required outcome and the possible outcome. The required outcome is the one you intend to pick, which is the red ball. That's the required outcome. Okay? The possible outcome is the total number of balls you have there, which you could pick. And that is 6 plus 8, that's 14 balls. So the probability of picking red will simply be what? Required outcome over possible outcome, and I have 3 over 7. That is the definition. That is what we really mean by probability. So let's go into some common terms in probability. One of it is what we call the sample space. And what is the sample space? The sample space, I'll still use this explanation. The sample space is, of course, the possible outcome. So when we say sample space, we are talking about the possible outcome. So the sample space we are looking at here, that is your sampling in statistics. When we say sampling, that means what is the total number of balls we are considering? We're considering 8 red ball and 6 yellow ball and 8 yellow balls. So the total event, the total sampling, which is the sample space there, is what? Is 14. That's 8 plus 6. That's the sample space we are looking at. The event space is the real event we want to look at. The event space is the required outcome. For this case, what's the event space? The event space, of course, you can guess is what? Is the 6 balls. So here we have sample space of 14, which is the total balls I'm looking at. Then the event space, I have what? I have 6 red balls, which is the total number of balls I'm considering. Of course, we also have something called the complement probability. What's complement probability? Complement probability is the probability that that event will not occur. probability of not getting the event. Okay? So for example, the complement probability here is our probability of not picking a red ball. Okay, that's what we mean by complement, when the event does not occur. And probability complement, probability not event, is 1 minus probability of the event. That's getting the complement of the probability. That is, we call this, for example, we can use set notation, of course. We can use set notation. In set notation, probability simply means, let's say this event here is P. Let's say the event is P, and that is 1 minus probability of the event. So P here is the event. Why this one is the complement event. Complement event. So for example, the complement event, when it comes to this probability complement, I'm still using the example here. The complement event, okay, some people use I, some people use E. The complement event here will be 1 minus probability of picking what? Probability of picking a red, and that is 1 minus 3 over 7, and that is 4 over 7. So when we say complement simply means the probability of not doing that thing. And that is 1 minus probability of doing that thing. So what we have here telling us that the complement is 1 minus the probability of the event simply shows that there is no probability that can be more than 1. You cannot have a negative probability, neither can you have a probability that is greater than 1. So for any probability of any event, the range of the probability is always between 0 and 1. And that means you should be very careful anytime you are looking for probability. None of the probability can be negative, that is less than 0, or none of the probability can be greater than 0. Okay? And when you have probability of an event to be 0, that means the event can never occur. Events that can never occur. That can never occur. Okay? Such as probability of getting a 7 from a fair die. Okay? A fair die has 1 to 6. So the probability that you are going to get a 7 from tossing a fair die is definitely 0. Okay? Then probability of a sure event is 1. So a sure event. So probability of sure events is always 1. Okay? That an event will always occur. The probability is 1. So we have different types of events. The very first type of event that we're going to look at is the mutually exclusive event. Mutually exclusive event. Mutually exclusive events. The easiest way of remembering the mutually exclusive events is the yawning and whistling concept. The yawning and whistling. Yawning and whistling. Yawning plus whistling. Is there anybody that can achieve that? Can you yawn and whistle at the same time? It's not possible. Not possible. Okay? So a yawning and whistling event is a mutually exclusive event because the two events cannot occur at the same time. So when we say mutually exclusive events, we're simply talking about events that cannot occur at the same time. So events that can't occur together. They can't occur together. They are mutually exclusive events. That is, you can never have and for such events. So if you have if X and Y are mutually exclusive, if they are mutually exclusive, then that simply means probability of X and Y is 0. It can't occur because the two events cannot occur together. You cannot whistle and yawn at the same time. But you can have probability of X or Y. The or is possible. And that simply means probability of X or Y is probability of X plus probability of Y. Because it's very, very possible. So when we add probabilities this way, it simply means that the probability could occur. It's either this occur or this occur. Let's look at a simple example question. In the tossing of a die, what is the probability of getting a 2 or a 6? Okay, when you have a die, what is the required outcome? What is the event space? The event space that we're looking at is the 2 or 6. The sample space is 6, which is the total number of events that is possible. We could have 1 to 6. So probability of 2, probability of getting a 2 is what? Is 1 over 6 because you only have 1 of 2 on a die, just a die. The probability of getting a 6 is also 1 over 6. You also have 1 of 6 on a die. So probability of getting a 2 or 6, you can't get both of them. If you toss a die now, it's either you get a 2 or a 6. Probability of getting a 2 and a 6 is 0. Both cannot occur. So probability of getting a 2 or 6 is probability of getting 2 plus probability of getting 6. And that is what? 1 over 6 plus 1 over 6. And that's what? 1 over 3. That's the probability of getting. So when it comes to some events that you can only add this way, those events are what? Mutually exclusive events. The way we look at independent events, which is the second part of this, the other type of this event, one is mutually exclusive, the other one is the independent events, are the events that can coexist. You can have the two events occurring at the same time. So events like that are said to be independent. That's the meaning of independent. Independent means they don't really affect each other. This could occur and this will also occur. So these are events that can occur simultaneously. They can occur simultaneously. So that means the or and the and is possible. Okay? Or and are what? Possible for such events. It's not like that of mutually exclusive. In mutually exclusive, only or is possible, and is not possible. But in independent events, or is possible and is also possible. So if x and y are independent, if they are independent, then probability x and y will simply be probability of x times probability of y, because both of them can occur. You can have and. Then probability of x or y occurring with probability of x plus probability of y minus probability of x and y. So you can have the or and you can have the and that is why when we're doing the or, we have to subtract the and. It's just like I said. Look at it. Probability of, let's say this is x and y. This is independent event. You can have both of them in your set. You can have intersection. So probability of getting x or y, that's probability x union y, is probability x plus probability y minus probability x intersection y. So this is in set notation. Why this is in probability notation? It's still the same thing. Probability that you are going to get x or y is this shaded portion. This is probability x or y. So for you to get that shaded portion, you need to find probability of x, probability of y, minus probability in both of them. That will give you probability that, okay, it is either doing x or doing y. We have events that can take this. Event that can take this, we have multiple picking. Yes, now. You can have multiple picking. You can pick red ball now and still pick another red ball. I'll show you what I mean now. Okay, this is a typical example of independent events. You can have when you have two coins being tossed at the same time, and probability of getting a head and tail. Yes, now it's possible you can have head and tail. You have head in this coin and tail in this coin, or you have tail in this coin and head in the other coin. So it is very, very possible that we have head or tail. So probability a head or tail will be probability head and tail, or tail and head. Okay, it could be the first one that will have head and the other one will have tail, or the first one will have tail and the other one will have head. Okay, so but in the tossing of the coin, probability of the tail is 1 over 2, because we have two sides. Probability of head is also 1 over 2. Okay, so probability a head or tail will be what? What we have here, let's transmit it here. Probability head and tail, that's 1 over 2 times 1 over 2, head and tail, or tail and head, 1 over 2 times 1 over 2. What do we have there? This is 1 over 4 plus 1 over 4. Final answer is what? 1 over 2. So probability of getting a head or tail in any of these cases is 1 over 2. Instead of using this method, which is just the explanation in terms of the head and tail and head, you can also use the table, which I'm going to explain in the next video. You can use the table for the first coin, and the second coin. The first coin has head or tail possible. The second coin has head or tail possible. So when you toss the two of them, it's possible we have head, or we have head tail, or we have tail head, or we have head, or we have tail tail. I mean, that's for the first combination of the first and the second coin. So the probability that you're having head or tail in any of them, head and tail, is this and this out of the sample space of what? Of 4. So probability head and tail is simply what? 2 out of 4, which is 1 over 2. So that correlates with what we got using the verbal explanation. Look, the whole thing behind mutually exclusive and independent events is that when it comes to independent events, we can have or and and. Look at what we have here. We have or and we have and. We have head and tail and head, then head tail or tail head. This is only possible in independent events. And independent events are multiple events where you have like 2 coins, or you have 2 dice, or you have a dice and a coin, and things like that. Remember to drop a comment on our video and like us. We expect more video from you, okay? Thank you.